is a pervasive notion, almost a mechanic's folklore, that upwards of 70% of all catastrophic engine failures don't begin with a sudden, dramatic breakdown, but rather with a series of quiet, seemingly insignificant habits. These are the subtle routines and overlooked details that drivers adopt, often without a second thought. The majority of car owners resign themselves to an unspoken truth, that their engine will inevitably lose its power, its responsiveness, and its smoothness as the miles accumulate. They accept this degradation as a simple function of age. However, this is a conditional reality, a self-fulfilling prophecy that only comes true if you allow it. In today's deep dive analysis, we are going to dismantle that notion entirely. We will reveal the specific, actionable strategies you can implement starting this very day to make your engine perform with the crisp precision and potent energy of a vehicle that just rolled off the assembly line, even if its odometer tells a story of over 150,000 miles. Furthermore, we will expose a widespread and seemingly benign habit that is silently waging a war of attrition against modern engines, particularly in the high-stress environment of stop-and-go city traffic. It is time to move beyond simple tips and immerse ourselves in the core principles of automotive longevity. If this caliber of in-depth, no-nonsense knowledge about the preservation of your machine is what you're searching for, then demonstrate your commitment by hitting that like button and, more importantly, subscribing to the channel. Ensure you activate all notifications, because the information we disseminate here is meticulously crafted for one purpose: to keep your vehicle performing at its peak on the road and to keep your hard-earned money secure. Number 12. The flawed morning ritual, a misunderstanding of the modern warm-up. There was an era, not so distant in the grand scheme of automotive history, when the universally accepted wisdom was to let your car idle in the driveway for a solid 5, 10, even 15 minutes before daring to shift it into gear. This was especially considered gospel on a frosty morning. It was a mechanical sacrament, a piece of popular belief passed down through generations, from father to son, like a family heirloom. But within the precise and unforgiving context of modern automotive engineering, that entire practice has been rendered not just obsolete, but actively detrimental. Today's engines, with their sophisticated computer-controlled direct fuel injection systems, variable valve timing, and advanced multi-grade synthetic oils, are engineered for a level of operational efficiency that is nearly instantaneous from a cold start. They are designed with the expectation of movement. They need the dynamic load of gentle driving to achieve their optimal operating temperature in a uniform and controlled manner. Forcing a modern engine to sit and idle is fundamentally at odds with its design. It's akin to instructing a world-class sprinter to perform static stretches in a walk-in freezer just before a 100-meter dash. Their muscles will become stiff, their reaction time will suffer, and their overall performance will be severely compromised. The correct, engineer-approved strategy is a study in simplicity and efficiency. Start the engine. Allow approximately 30 to 45 seconds. This is not an arbitrary number. This is the crucial window of time required for the oil pump to build sufficient pressure throughout the system, ensuring that the lifeblood of the engine, the lubricant, has reached the most remote and critical components, from the camshaft lobes to the crankshaft bearings. After this brief interval, you engage a gear and begin to drive, but with a conscious gentleness. For the first several miles, avoid any semblance of aggressive acceleration or Number 11. The perils of oil procrastination. Misinterpreting the role of lubricant. It's one of the most common temptations in vehicle ownership. The sticker on your windshield or the owner's manual clearly states an oil change interval of, say, 7,500 miles. But, as that number approaches, you tell yourself you can stretch it. 8,500, maybe 10,000 miles won't hurt. After all, modern full synthetic oils are touted as miracles of chemical engineering. Aren't they supposed to last practically forever? This line of reasoning is often reinforced by well-meaning but ill-informed advice from friends or family. The same folks who might suggest using a stop leak additive as a permanent fix for a radiator leak. This mentality, however, is a high-stakes gamble with your engine's life. The role of engine oil extends far beyond mere lubrication. It is a multifaceted, dynamic fluid performing several critical tasks simultaneously. First and foremost, it is a cleaning agent, a janitor for the engine's internals. It contains a complex package of detergents and dispersants designed to suspend and carry away a host of harmful contaminants. These include soot particles from combustion, acidic byproducts, microscopic metal shavings generated by normal wear, and the dreaded sludge that forms from the high-temperature oxidation of the oil itself, combined with moisture. Over thousands of miles and countless heat cycles, the additives in the oil become depleted. The total base number, TBN, which measures the oil's ability to neutralize acids, drops precipitously. When the oil becomes old and saturated, it loses its capacity to perform these vital functions. It ceases to be the engine's guardian and morphs into a thick, abrasive slurry. This degraded oil can no longer effectively protect the components. Instead, it begins to clog narrow oil passages, block the oil pickup tube screen, and essentially starve critical parts like the valve train and turbocharger of lubrication. The oil filter, while a critical and heroic component, has a finite capacity for trapping these contaminants. It is not engineered to compensate for months of neglect and an oil sump full of sludge. Number 10. The engine's respiratory system, the mass air flow (MAF) sensor. Herein lies a component that exists in a state of obscurity for the average car owner. Most have never heard of it, let alone considered it a maintenance item, the mass airflow sensor, or MAF. The name may sound intimidatingly technical, but its function is a masterclass in elegant simplicity. Positioned in the intake tract, directly between the air filter housing and the engine's throttle body, its singular critical purpose is to precisely measure the mass of the air entering the engine's combustion chambers. It does this typically by heating a very fine platinum wire or film, and then measuring the electrical current required to keep it at a constant temperature as the incoming air cools it. More air mass requires more current. This data, a constant stream of information, is fed directly to the ECU. The ECU then uses this primary input to perform its most critical calculation, the precise amount of fuel to inject to achieve the ideal, or stoichiometric, air-fuel ratio, approximately 14. 7 parts air to 1 part fuel for gasoline. In the simplest terms, the MAF sensor is the component that tells the engine's brain exactly how much to breathe. Over the course of its life, this highly sensitive sensor becomes progressively contaminated. A microscopic film of dust that bypasses the air filter, oil vapor from the PCV, positive crankcase ventilation system, pollen, and other airborne grime tenaciously adheres to the delicate sensing element. The effect is analogous to placing a layer of gauze over a thermometer. It can still sense temperature, but its readings become slow, insulated, and inaccurate. A contaminated MAF sensor consistently underreports the actual amount of air entering the engine. This faulty data causes the ECU to Number 9. The clogged arteries, the fuel, filter, and injectors. While the MAF sensor ensures the engine knows how much air it's getting, the fuel system is responsible for delivering the other half of the combustion equation with equal precision. Over time, this system can become progressively clogged and inefficient, leading to a slow, parasitic drain on performance and economy. The first line of defense is the fuel filter. This component, often neglected for the entire life of the vehicle, is tasked with trapping rust, sediment, and other debris that can accumulate in the fuel tank or be introduced during refueling. As the filter becomes clogged, it restricts fuel flow, forcing the fuel pump to work much harder to maintain the required pressure at the fuel rail. The initial symptoms can be subtle, a slight hesitation under hard acceleration, or difficulty starting. As the clog worsens, it can lead to engine sputtering, stalling, and eventually the premature failure of the overworked fuel pump, a repair that can be quite expensive. Adhering to the manufacturer's replacement interval for the fuel filter is a simple, proactive measure to prevent this cascade of problems. However, the real choke point in a modern fuel system is often the fuel injectors themselves. These are incredibly precise electromechanical valves with microscopic nozzles, pintles, designed designed to atomize fuel into a fine, cone-shaped mist for optimal combustion. Over time, carbon deposits and fuel varnishes, byproducts of the combustion process and additives in the gasoline, can bake onto the injector tips. This accumulation disrupts the spray pattern, causing the fuel to drip. Number 8. The forgotten lungs. The engine air filter. This point is so elementary, so fundamental to the very concept of an internal combustion engine that its importance is frequently and inexplicably overlooked. Imagine being forced to run a marathon while breathing through a thick, dusty blanket. That is not an exaggeration. It is a mechanically accurate analogy for what your engine endures when its air filter is clogged. The internal combustion engine is, at its core, a sophisticated air pump. For every gallon of gasoline it consumes, it must inhale and process a staggering volume of air, upwards of 10,000 gallons. That air must be spotlessly clean. The air filter is the sole guardian standing between the outside world and the delicate, precision-machined internals of your engine. Over time, this filter element becomes saturated with an incredible amount of debris: dust, sand, pollen, insects, soot, and road grime. As the filter media becomes clogged, the engine has to struggle, creating a significant vacuum in the intake tract just to draw in the air it desperately needs. This restriction has a cascade of negative effects. The engine's volumetric efficiency plummets, meaning it can't take in a full breath of air on each intake stroke. This directly translates to a noticeable loss of horsepower and torque. The ECU may try to compensate for the lack of air by adjusting fuel trims, but this often leads to an overly rich mixture, which wastes fuel, fouls spark plugs, and can, over the long term, damage the expensive catalytic converter. The result is sluggish acceleration, a strained engine sound, and a significant drop in fuel economy. Changing an engine air filter is number 7. The engine's bodyguard, the cooling system. The coolant, or antifreeze, circulating through your engine is far more than just a colored liquid. It is the engine's personal bodyguard, its dedicated thermal regulation system, and its internal anti-corrosion agent all in one. Its most obvious job is to fight a war on 2 fronts: preventing catastrophic overheating in the blistering heat of summer traffic, and preventing the coolant from freezing solid and cracking the engine block in the depths of winter. But its responsibilities run much deeper. The coolant is formulated with a complex package of chemical additives designed to prevent rust and corrosion on every dissimilar metal surface it touches, from the iron of the engine block to the aluminum of the cylinder head and radiator, and the brass of the heater core. Without these protective additives, a process called galvanic corrosion would rapidly eat away at the engine from the inside out. The critical mistake that countless drivers make is assuming that coolant lasts forever. It does not. Over time and exposure to extreme temperatures, its crucial additives are consumed and break down. The pH level of the coolant drops, and it becomes acidic. That once vibrant green, orange, or pink fluid transforms into a murky, brown sludge, laden with rust particles, scale, and other abrasive contaminants. At this stage, the coolant ceases to be a protector and becomes an aggressor. This corrosive and abrasive slurry is forced through the incredibly narrow passages inside the radiator tubes, the heater core, and the water jackets surrounding the cylinders. As it flows, it deposits scale and sludge, creating block number 6, the gatekeeper of temperature, the thermostat. Here is a fascinating and terrifying fact of automotive mechanics. Your car's thermostat is an incredibly simple, inexpensive wax pellet valve whose sole function is to open and close at a predetermined temperature. It typically costs less than a decent meal. Yet, when this humble component fails, it has the power to orchestrate the complete and utter destruction of your entire engine. A thermostat that fails in the closed position becomes a deadly trap. It blocks the flow of coolant from the engine to the radiator, effectively turning the engine block into a sealed pressure cooker. The coolant inside the engine will boil within minutes, causing a massive spike in pressure and temperature. This is when you see the temperature gauge shoot into the red, steam erupt from under the hood, and you are faced with the immediate immediate prospect of a warped cylinder head, a blown head gasket, or a cracked engine block, repairs that run into the thousands of dollars. Conversely, a thermostat that fails in the open position creates a different, more insidious set of problems. It allows coolant to circulate constantly to the radiator, never giving the engine a chance to reach its proper operating temperature, typically 195 and 220 degrees C or 90, 104 degrees C. An engine running too cool is inefficient. The ECU remains in its open-loop warm-up mode, injecting a rich fuel mixture, which devastates fuel economy. The engine oil never gets hot enough to burn off accumulated moisture. Number 5. The transmission's lifeline, the ATF. If engine oil is the blood of the engine, then automatic transmission fluid, ATF, is the highly specialized lifeblood of the transmission. It is one of the most complex fluids in any vehicle, serving as a hydraulic fluid to actuate clutches and shift gears, a friction modifier to ensure smooth clutch engagement, and a coolant to dissipate the immense heat generated by the torque converter and clutch packs. Yet, it is tragically one of an automobile's most forgotten fluids, often ignored until the transmission begins to shudder, slip, or refuse to shift altogether. At that point, the damage is already done, and a repair costing thousands is imminent. ATF degrades over time. The constant shearing action of the gears breaks down the viscosity modifiers in the fluid, while the extreme heat causes it to oxidize. Old, oxidized ATF loses its lubricating properties and its ability to manage friction, leading to harsh shifts and increased wear on the transmission's internal components. It also becomes saturated with microscopic particles of friction material from the clutches. This abrasive fluid then circulates throughout the intricate valve body, where it can clog tiny passages and cause solenoids to stick, leading to erratic shifting behavior. Don't wait until you're stranded. Most manufacturers recommend a transmission fluid and filter change at intervals ranging from 30,000 to 60,000 miles, but this can vary greatly, especially for vehicles used for towing or in severe conditions. Following this schedule proactively can easily double the life of your transmission, saving you from one of the single most expensive repairs a car owner can face. Number 4. The spark of creation. The spark plugs. Spark plugs are small, deceptively simple-looking components, yet they are the focal point of the entire combustion process. They are the high-voltage heart surgeons of your engine, tasked with delivering a perfectly timed high-energy spark, up to 40,000 volts, to ignite the compressed air-fuel mixture thousands of times per minute. If even one spark plug is worn, fouled, or has an incorrect gap, the entire symphony of the engine's operation is thrown into disarray. A weak or inconsistent spark leads to incomplete combustion, a condition known as a misfire. This can manifest as a noticeable engine hesitation, a rough and shaky idle, a significant loss of power, and a dramatic drop in fuel economy. Worst of all, a persistent misfire allows unburned fuel to be dumped into the hot exhaust system, where it can rapidly overheat and destroy the precious metals inside the catalytic converter, turning a simple maintenance issue into a multi-thousand-dollar repair. Most drivers forget about their spark plugs until it's far too late. The replacement interval can vary dramatically depending on the type, from as little as 30,000 miles for standard copper plugs to over 100,000 miles for modern iridium or platinum plugs. Treating this replacement as a non-negotiable part of your maintenance schedule is like giving your engine a regular therapy session. It ensures clean, efficient combustion. Number 3. The sin of aggression. Constantly flooring the accelerator. The visceral thrill of stomping the accelerator pedal to the floor, feeling the surge of power as you're pressed back into your seat, can be addictive. It feels like you're unleashing the full, untamed potential of your machine. But every single time you subject your car to this kind of wide-open throttle abuse, especially from a standstill, you are trading a fleeting moment of excitement for a measurable reduction in the lifespan of your engine, transmission, and entire drivetrain. Flooring the accelerator forces the engine into its highest stress state of operation. It puts maximum strain on the pistons, connecting rods, crankshaft, and bearings. If this is done regularly, especially before the engine is fully warmed up and the oil is at its optimal viscosity, you are causing accelerated wear on a microscopic level that accumulates over time. For the transmission, this shock loading is even more brutal. It forces harsh, high-pressure downshifts and places immense stress on the clutch packs, torque converter, and planetary gear sets. This habit is a surefire way to shorten the life of an automatic transmission. The intelligent way to drive for longevity is to treat the accelerator pedal not as a binary on-off switch, but as a rheostat, a gradual controller. Squeeze into the power, don't stomp on it. Allow the engine and transmission. Number 2. The empty roar, revving the engine in neutral. We understand the impulse. Revving the engine in neutral or park produces a satisfying, aggressive growl that can make you feel like you're on the starting line of Le Mans. But unless you are a mechanic performing a specific diagnostic test, revving a stationary engine is, mechanically speaking, one of the most pointless and damaging things you can do. It is particularly destructive to do this when the engine is cold. As previously discussed, the oil has not had time to properly circulate or reach its operating temperature. When you snap the throttle open and send the RPMs soaring, you are forcing components like the pistons, bearings, and valve train to accelerate and decelerate at incredible speeds with inadequate lubrication. You are essentially grinding metal against metal. Even when the engine is warm, revving it without a load is still detrimental. An engine is designed to operate under load. That's what keeps forces balanced and components seated properly. Revving it freely can cause rod stretch and puts unnecessary stress on the valve train components like valve springs and keepers. It burns fuel for no reason and serves no purpose other than to create noise and accelerate wear. Your engine is a finely tuned instrument, not a rock concert amplifier. Let its smooth, quiet, and responsive operation be the testament to its health and power. Number 1. The ultimate detox, a professional intake system cleaning. If your engine had a voice, it would eventually begin to beg for this one specific service. Over many thousands of miles, especially in modern gasoline direct injection (GDI) engines, a hard, baked-on layer of carbon deposits accumulates in the intake manifold, on the throttle body, and most critically, on the backside of the intake valves. In a traditional port-injected engine, gasoline is constantly sprayed over the intake valves, keeping them relatively clean. But in a GDI engine, fuel is injected directly into the combustion chamber, so the intake valves are never washed by this cleansing spray. Oil vapor from the PCV system and exhaust gases from the EGR, exhaust gas recirculation system, are drawn into the intake and bake onto the hot valves, forming thick carbon deposits. This carbon buildup acts like a sponge, soaking up fuel and disrupting the carefully engineered airflow into the cylinders. It chokes the engine, restricting its ability to breathe. This leads to a host of problems: a rough idle, hesitation, misfires, poor fuel economy, and a significant loss of horsepower. It slowly and silently transforms your once smooth and responsive engine into a rough, sluggish, and inefficient mess. This is where professional full intake system cleaning becomes not just a maintenance item, but a restorative procedure. This service uses specialized solvents and equipment to break down and flush out all of the performance-robbing carbon deposits from the engine's entire respiratory tract. The results of this service can be truly transformative. Drivers often report a dramatically smoother idle, a return of the crisp throttle response they thought was gone forever, improved acceleration, better fuel economy, and, in some cases, a measurable restoration of lost horsepower. It won't magically add power the car never had, but it will reclaim the power that carbon has been quietly stealing over the years. This is a procedure most drivers have never even heard of, and it's rarely mentioned by service advisors. But performing this service every 40,000 to 50,000 miles will keep your modern engine breathing freely, running cleanly, and performing at its peak for many years to come. There you have it. A comprehensive breakdown of the most insidious habits, overlooked fluids, and forgotten components that could be silently orchestrating the premature death of your engine. Some of these solutions cost mere pennies and a few minutes of your time. Others simply require a conscious shift in your mindset and habits. But left unchecked, every single one of them has the potential to bleed your wallet dry and leave you stranded. If you have learned even one new, valuable piece of information today that will empower you to better care for your vehicle? Then do us a favor and hit that like button. And if you haven't already, subscribe to the channel for more real-world, no-nonsense automotive advice that actually makes a difference. There is a video appearing on your screen right now that we have specifically selected to save you even more money and stress under the hood. Click it now, and I'll meet you over there.